Dear students, today I am going to explain you some numericals in physics on work and energy and heat for board examinations. First question is a car weighing 1000 kg and traveling at 30 meters per second stops at a distance of 50 meters, decelerating uniformly. What is the force exerted on it by the brakes? What is the work done by the brakes? So we have been given here that initial speed, that is a small u, equals to 30 meters per second. Final speed is small v, that is 0. So whenever any moving object stops, then v is 0. And whenever an object starts from rest, then u is 0. That is initial speed is 0. And acceleration equals to a, that we have to find out. And distance covered after applying brakes equals to 50 meters. And for distance here we will write s. Now from third equation of motion we know v square equals to a square plus 2s. This implies v square minus u square equals to 2s. And this implies a equals to v square minus u square by 2s. Here v is 0, final velocity is 0, so 0 square minus u is 30, so 30 square by 2 into 50. So 0 square is 0 and 30 square is 900 by 100. 0 minus 900 is minus 900 by 100. 0, 0 cancelled and that is equals to minus 9 meter per second square. So this is deceleration we have got. That is acceleration here. And so here when we are writing a, then minus we are writing for deceleration. Now force exerted by the brakes, that is F equals to mass into acceleration. So force is here 1000 and acceleration is minus 9, that is minus 9000 Newton. Here you find that it is negative sign. So negative sign shows that it is a retarding force. Whenever brakes are applied, then retarding force is acting upon the moving object and the moving object stops. So the work done by the brakes is equals to W, and that is equals to force into displacement. So here W equals to force, already we have calculated 9000 Newton, and displacement is 50 meter, that is equals to 4,50,000 joule, and that is equals to 4.5 into 10 to the power 5 joule. Yeah, this is an scientific notation. Now, second question is from heat. Question is 10 kg of hot water in a bucket at 70 degrees Celsius is cooled for taking bath by mixing 20 kg of water at 10 degrees Celsius. So what is the final temperature of the mixture, neglecting the thermal capacity of the bucket? So first of all, we are supposing that the final temperature of the mixture be x degrees Celsius. Now case 1. Here mass of hot water is given m1, that is equals to 10 kg. Specific heat of hot water, that is C1. Initial temperature of hot water, that is T1. Oh, it is not T1. It is 70 degrees Celsius. And final temperature of the mixture is x degrees Celsius. So falling temperature of hot water, that is T1, and that is 70 minus x, because the temperature of the mixture is smaller than the temperature of the hot water, because it is losing the temperature. So the temperature of the falling temperature of hot water is 70 minus x, that is T1. Now heat lost by hot water equals to Q1, that is M1 into C1 into T1, that is mass into specific heat capacity into temperature. So Q equals to, that is Q1 equals to 10 into C1 into 70 minus x. This is equation 1. Now case 2. Mass of cold water is equals to M2 equals to 20 kg. Specific heat of cold water, that is C2. Initial temperature of cold water is 10 degrees Celsius. Now final temperature of mixture is X degrees Celsius. Therefore, rise in temperature of cold water, because cold water is accepting the heat from hot water, and hot water is hot water is losing the heat. That's why here you find that mixture's temperature is more than the temperature of cold water. That's why rise in temperature is T2, that is X minus 10 degrees Celsius. Okay. So heat gained by cold water is gaining the heat, and that's why Q2 equals to M2 into C2 into T2, that M2 is mass of the cold water, C2 is specific heat capacity of cold water, and T2 is gain in temperature, that means cold water gains in temperature. So this Q2 is equals to 20 into C2 into X minus 10. This is equation 2. And according to the principle of calorimetry, we know that heat lost by hot water equals to heat gained by cold water. It is obvious that if something is losing heat, other object will gain it, and then only if both are in contact, there will be equilibrium in temperatures. That means both temperature will be equal. So Q1 equals to Q2 here. So Q1 value is 10 into C1 into 70 minus X equals to Q2 is 20 into C2 into X minus 10. Now here you see specific heat capacity of hot water and cold water both are equal. That's why C1 equals to C2, and so C1 and C2 are cancelled. And now we are removing the bracket. So 10 into 70 is 700 minus 10 into X is 10X. 20 into X is 20X minus 20 into 10 is 200. Now this 200 is coming left side, so it becomes 700 plus 200. And this minus 10x come right side, so it becomes plus, so 20x plus 10x. So 900 equals to 30x, and therefore x equals to 900 by 30 equals to 30 degrees Celsius. This is the temperature of the mixture. That means mixed water. Okay. Thank you. If you like, please share and subscribe.